Alright, this is the algebra screencast for 3.2. It is titled Graph Linear Equations. We're going to be graphing linear equations in this section by using a table. And this is the first way you usually end up learning how to graph linear equations, is by using a table. Part of this section, though, they have us checking solutions to tell whether or not an ordered pair is a solution of the equation. We've done something similar to this before, except it was only with one variable. It's just now it's with two. So you're going to put in the x and the y and substitute that in, and if you get a true statement, then it is a solution. If you don't get a true statement, then it's not a solution. Lovely ordered pair, just not a solution for our equation. So for section A, or part A, we'll have 2 times 3 plus negative 2. We're checking to see, does that actually equal 4? So 2 times 3 is 6 plus negative 2. Does that equal 4? 6 plus negative 2 is 4. 4 equals 4. Both sides equal. This one checks out. That means that negative 2, 3 is a solution. We'll do the same thing in part B. We have negative 2, 3 actually for the same thing. So if we plug negative 2 in for x and 3 in for y, we'll have 3 plus negative 2. We're checking to see, does that actually equal 2? 3 plus negative 2 is 1. 1 never equals 2. So that means for this equation, negative 2, 3 is not a solution. Okay, so this one, it did work, it was a solution. Second one, not a solution. Okay, probably the thing you have to be most careful about is that you put the x coordinate in for the x value and the y for the y. A lot of times we just see the first variable and the first coordinate, and we want to just put them in order like that instead of paying attention. But you do have to pay attention and put things into the correct order. Alright, so when we do graph equations with two variables, so think of the slide before, x and y, that's two variables, we're going to make a table of values. We want to be able to graph enough solutions so that we can recognize a pattern. And then we'll connect the point with a line or a curve. And actually for what we're doing in this section, I should do that in black here. In this section, because it's all on linear equations, it's going to be a line. If your points don't look like they're in a line, you made a mistake someplace. What ends up happening is that the graph shows all the solutions of the equations. So there's infinitely many. We can't list all those. That's why we have a graph. So just another note here, the solution of an equation with two variables is every ordered pair that gives a true statement. So there could be more than one. There could be lots and lots and lots, like we mentioned before, infinitely many. So when you're graphing enough solutions to recognize a pattern, some people say 3, some people say 5. 3 is kind of skimpy because you could be making a mistake in a couple of them and not realize it. So bare minimum is 3. 5 is probably even better. And you want to make sure that they're far enough apart that you can see the pattern. You don't, depending on the numbers, you don't want them so close you can't even see where the line is. So make sure you choose things that are good things. Alright, so for example, our first one, we want to graph the function y equals opposite of x minus 1. Make a table. So I'm going to choose -2, -1, 0, 1, 2. Those are probably the more common ones that you'll pick. Your y is the opposite of x minus 1. So here we'll have opposite of -2 minus 1. So that's 2 minus 1, which is 1. And then we'll have the opposite of -1 minus 1. 1 minus 1 is 0. If we put in 0, we get -1. If we put in 1 as our input, we'll have -1 minus 1. And then -2, opposite of 2 minus 1 equals -3. And remember, last section we said this creates ordered pairs. So we have the ordered pairs -2, 1, -1, 0, 0, -1, 1, -2, 2, -3. So when you go to graph these, your graphs will be much nicer on your graph paper than mine drawn by hand on here. So we have -2, 1, -1, 0, 0, -1, 1, -2, and you can kind of see the pattern here, 2, -3. And again, remember we said they should be linear, so you should be able to draw a line. These are ones you do want to draw a line because that whole line is going to represent solutions. So draw your line as best you can, and on your homework I'm sure you use a straight edge to make it much nicer than what this was. So all these ordered pairs that are along here, every single one, all of these are solutions to our equation. We just happen to use 5 of them to be able to draw that. So you can see if you make a mistake in your table, it throws off your graph. So be careful about that. Alright, there are special cases. Horizontal lines. Basic definition is that y equals c is a horizontal line. It'll go through the ordered pair 0, c. So for example, we'll do a quick little example. Y equals 2. If y equals 2, that means x can be anything. Y is always, always, always going to be 2. So we'd have a horizontal line that looks like this. Y is always 2. And this ordered pair here would be 0, 2 for our specific case of y equals 2. Vertical lines, they have the equation x equals some number. So let's say we use x equals -2. This is our coordinate plane. If x is -2, that means y can be anything. So here's x is -2. That means this ordered pair right here is -2, 0. It's kind of opposite of what we think it should be, just because we think, oh, the y-axis, that's vertical, that must be for y equals 2, but it's actually the opposite. So just try and remember that, and then for x equals some number, that's the vertical one. Y equals a number, that's the horizontal. So it's backwards of what we think we feel it should be, or what we're thinking in our heads, because we're thinking, oh, y equals 2, that'll be parallel or look just like the y-axis, but it's not. It's the opposite. So be careful about those. Your homework does bring this up a little bit. So you'll have ones like these that say graph the following equations. And the way I always think of it, because sometimes I get mixed up too, is that if y equals -2, x can be anything. So let's see, y -2, if I go down 2, here's -2. Okay, so that's 0, -2. That means no matter what the x is, y is going to be -2. If I have 1 -2, that would be here. If x is 2, y is still -2, it would be here. And you could do the same thing on the negative side. If x is -1, y is always going to be -2, because that's what we were told this equation was going to be. And then you can see, oh, it's horizontal. Okay, let's try the next one. B, x is -3. If x is -3, 1, 2, 3. If x is 3, that means y can be anything. So our ordered pairs could be 3, 0, 3, 1. We'll just write them down this time. 3, 0, 3, 1, 3, -1. It could be 3, 25, whatever it might be. But you're always going to go over to 3 and then either up or down, however many you need to, whatever your y is, because y is anything. Okay, if x is 3. And then you can draw your line. Okay, so if it helps you, you could still make a table for these. You know, you could make a table like that. X always has to be 3 though, for our example here. And then you can just choose whatever you want for y. It doesn't really matter. But x always, always, always has to be 3. So you could still do these with tables. Alright, this one. These are a little bit different. Taking it up a notch. We're going to graph the equation. And then we also want to identify the range of the function. And we are given that y equals 3x minus 2. What's interesting about these is now we're told the domain is greater than or equal to 0. So that means whatever we put in for the x, it has to be greater than or equal to 0. So I'm going to start with 0 because x could be 0. And then I'll do 1, 2, and then we'll just do 3. Okay, and then we can figure out the y. If we put in 0, we'll get -2. If we put in 1, 3 minus 2 is 1. If we input 2, 3 times 2 is 6, minus 2 is 4. And then the last one, 3 times 3 is 9, minus 2, 7. So I have the ordered pairs -2, 0, -2, 1, 1, 2, 4, and 3, 7. So if we graph those, and again your graphs will look much nicer on your graph paper. So we have the ordered pair 0, -2, and then 1, 1, and then 2, 4, and 3, 7. Okay, notice they're in a straight line, but remember we said we're going to draw a line. However, we have to stop at where x is 0. X has to be greater than or equal to 0. So we can't go to this side at all. So if we start here, it'll actually look more like a ray. So x is going to be greater than or equal to 0. That means all of our y values are going to be following this line. So notice y started at -2, so that means our range, our y, and notice all these other values got larger than -2, so y is going to be greater than or equal to -2. Because that's the first possible range number we could have was -2, because our first domain number was 0 that we were allowed to have. So all of our y values are going to be larger than -2. Notice we don't have anything down in this area for the y's. Okay, so it's taking it a step further. Alright, there's our homework as kind of pieces, parts, picking out the best homework, and make sure you follow any directions you were given in class.